this material goes back to chapter 1, but the sequencing part of our course puts it along with the chapter 5 material. So this is section 1.4, but it will be on the test number 3, and this material will be along with chapter 5. So on your homework, you'll be doing problems that involve exponents. The first section is about negative exponents, and this is one of the things that you probably haven't been exposed to as much. A negative exponent just means that the material or the information right here would have been in the denominator of a fraction. So it would still be the same information, but you're just going to move it to the denominator of the fraction. Now, whenever you have something that goes into the denominator, you can't just leave it sit there by itself, so you would have to put a 1 in the numerator. So if the exponent is negative, basically you're going to switch it to the bottom. Now, on the flip side of that, if the exponent is in the bottom and it's negative, then it's going to come to the top. So you'll see as we work through these examples what's going to happen. Now, the thing you have to remember is that an exponent is nothing but a shorthand explanation for a number being multiplied times a certain number of times, whatever the exponent tells us. Now, the other thing to remember is that the exponent is only connected to the number immediately to its left. So in this case, the 3 is only affecting the w's. The y to the negative 2 is only affecting the y's. So what we have here is that the w's, while the exponent is positive, is going to end up in the top. So basically we would have w over y, because the y has a negative exponent, so that would put 2 y's down in the bottom. But we don't want to have to write this out all the time, so we just have to remember and understand this is what it is. That's our think bubble. That's what we have to remember to think in our head. So if we're asked to simplify, if it's positive, it's going to stay right where it is. So this one's positive, so we're going to keep it in the numerator part of the fraction. The y is a negative, so now we're going to send it to the bottom. So this fraction, this would simplify out to being w to the third over y to the second. Now here, this is a numerical value that's being raised to a power, but because it's raised to a negative power, that means we have to take it, as we understand it, it looks like this. It's a whole number, and so we would put it over 1, but if we're going to put it to the bottom, we have to take the 3 to the 4th. When we move it, the negative comes off of it, because negative is kind of like the blinker. When you turn to the right in a car or you turn to the left, your blinker will go off. So when you switch the expression that has a negative exponent to the other side of the fraction bar, then the negative sign goes away from it. But I can't leave a fraction that doesn't have a numerator, so what I'd have to do is put it over the top of it. Now, this is a number that can be evaluated. So you can go in your calculator and you can say 3 raised to the 4th power. Now, when we raise to a power, you're going to use the little upside down key this will be the key that you need to use for raising to a power that's not a 2. You have an x squared key, but if it's a power different from 2, you would have to do 3 caret 4 to get your answer, and this would simplify out to be 1 over 81, because 3 to the 4th power would be 81. So you'll have to follow the directions on your homework. Sometimes they'll ask you to leave it in this form, sometimes they'll ask for it to be multiplied out. So on your homework, you'll have to follow the directions they ask for. In my case, on a test, I'm going to ask for this answer, because this would be the simplified form of 3 to the 4th, because numbers we can simply evaluate. Alright, so on number 3, I have a negative exponent on the top, and I also have a negative exponent on the bottom. So that just means the a's will all have to come to the bottom of the fraction. So I'm going to take my a's with the negative and move them to the bottom, and now it's a squared on the bottom. But my b's because they're negative on the bottom, they have to switch to the other side of the fraction. So then this would just be b to the 5th. So when you move it, once you move it, the negative sign goes away, and now we have our answers all in positive exponents. So that's one of the requirements, is that when you simplify something, you're not going to have an expression answer that has negative exponents in it. And your instructions will say, leave all exponents in positive, or all exponents must be positive exponents. Now, on this fraction, when you have a fraction raised to a power, what you're going to do is each of these numbers will get this power. So this would be 3 to the negative 2 over 5 to the negative 2. Now they both have negatives, so what that does is it basically flips the whole fraction around. So I would have 5 squared over 3 squared. Now those are numbers that can be simplified. So I would ask that they be simplified, so that would be 25 over 9 for your final answer. Here we would simplify it out to be 1 over 81. On these two, they're nothing more than variable expressions. As long as they don't have any negative on the exponents, should be good to go. Now, this problem is one that's a problem of contention. There is no negative exponent here. This is simply a negative number being raised to the second power. That second power means I'm going to write negative 3 times negative 3. So there's no negative exponent involved here. It's just negative 3 times negative 3, which would come out to be positive 9. So be careful that you know the difference between a negative number and a negative exponent. Okay? They have two totally different meanings. So don't just assume because there's a negative sign on a number that it has to do something. Okay? If it's only affecting a negative, it will only affect the exponent, and that's the only time that you would need to move it to the opposite side of the fraction bar. So that's the only thing to remember about negative exponents. We get down a little further, we'll talk about a little bit more of it. Now, property rule of exponents is x is a real number, and n and m are integers. So if x is a real number, and these are regular numbers, they're whole numbers, they can be positive or negative. If I want to multiply and the x numbers are the same, so x and x is the same, that means they have the same base, you would simply keep the base and you would add the exponent numbers together. Because this would mean, in this case, that I have r and r to be r squared, and here I would have 5 r's, r, sound like I'm barking, and then the last one would be another r. So how many factors of r do we have? You simply add. That's 2 plus 5 more would be 7, plus 1 more would be 8. So my answer simplified out would just be r to the 2 plus 5 plus 1 would be r to the 8th power. So if we're multiplying the factors of r, we add the exponents, and this r has 1 on it as an exponent. Okay, so over here, the 5 is the base, and it is the same number. So all I do is keep the base, that's 5, and I'm going to add the exponents, 3 plus 4, so that would be 5 to the 7th power. Now, this is a number that's going to get very large, so when you punch that in your calculator, you're going to use that caret key again. You're going to do 5 caret, it's an upside down V, 7, and it's going to give you a large number. On your homework, if you're asked to simplify this, you're going to leave it in this expression. Alright, here, our base is what's in the parentheses, because that's exactly the same on both of them. So this says I'm going to keep the 2x minus 1, and I have a 3 here, and I have a 2 here, so this would be to the 3 plus 2. So my final answer would be 2x plus 1, minus 1, keep it in parentheses, and raise it to the 5th power. That would mean that we would write 5 of these parentheses that would have to be multiplied together. We're not going to have to do that. But this would be your final answer in a problem like that. I'll circle these answers. Okay? Now, when you get to a problem like this, the 3 and the 5 are just multipliers. They're coefficients, so we're just going to multiply 3 times 5 because we know what those numbers are and we understand how to multiply. So I'm just going to multiply those together. That would be 15. And then with my bases, they're both x's, so I'm going to keep the x, and I'm going to combine their exponents together. So that would be 2 plus 6 for the x's, because I have 2 and then I have 6 more. So that means my final answer would be 15x to the 8th. Okay? The 2 on the exponent does not affect the 3. It only affects the number immediately to its left. The 3 is not being raised to a power. The 5 is not being raised to a power. The only factors here are multiple x's. Here I would have 2 x's. Here I would have 6 more. So I'd have 3 times xx, 5, and xxx, xxx. So I'd only have 1 3 and 1 5, which means 3 times 5 is 15. Now, if I multiply these, I'm still going to add my exponents together on the variables that are alike. So 3 times 6 is going to give me 18. For m's, I have a positive 5, and then I have a negative 1. So 5 minus 1 would be m to the 4th. And here on the ends, I have a 1 over here, so I have a negative 4 and a positive 1 would be n to the negative 3. Now, you can never leave negative exponents in your answer. And so the only one that has a negative is this one right here. Okay, so when you have a negative exponent, you're not done yet. That means I have to simplify that. So that means the expression with the negative exponent has to go to the bottom of your fraction. So the 18 and the m to the 4th will stay on the top and the bottom. Then n has to move down and it will become n to the 3rd on the bottom of the fraction. So we can never leave a negative exponent in our answer. Okay, on this next one, same thing happens. We're going to combine, we're going to multiply our numbers together. So 7 times 2 would be 14. My x's, I have 1 here, and I have negative 5. So 1 and a negative 5 would be x to the negative 4. And y's, I have a negative 2 and I have a negative 6. So I've lost $2 and lost 6 more. That means that would be y to the negative 8. Now, I don't want to leave negatives in my answer, and the x has a negative exponent and the y has a negative exponent. So both of those have to move, but the 14 is going to stay where it is. So my 14 stays on top, and my x to the 4th and my y to the 8th will move to the bottom of the fraction, and this would be your final answer. Okay, so simplifying exponents with the product rule. If the variable expression is the same or the numerical expression, that's called the base. If the base is the same, you simply add the exponents together. So here's your rule, basically. Keep the base, add the exponents. Now, this is multiplication. So if we're multiplying, we add our exponents. Now, here's the same thing. We're going to do the same process here, but it's reversed. So if we got a number on top with an exponent and the number on bottom with the exponent, what we're going to do is take the top number and subtract the bottom number. So here I have x to the 12 over x to the 3. Now, basically what that would mean is I would write out 12 x's, and then the bottom I would write out 3 x's. And so I would be able to cancel out the things that are the same. So I'm going to go ahead and show it in that way. I'm going to have 12 x's. That's 5, 6, 7, 8, 9, 10, 11, 12. So I've got 12 x's as factors on the top. And then in the bottom, I only have 3. 1, 2, 3. So every place that they're the same factor becomes a 1. X over x would be 1. So those cancel out. X over x would be 1, so I can cancel those out. X over x would be 1. I can cancel those out. So I took off 3 from the bottom and 3 from the top. So that means all the bottoms are gone. But taking 3 out of the 12 would leave me with x to the 9th. And see how all my x's are on top of the fraction? Then this would just be a whole number fraction. Okay, it would be like over 1. So everything stays on the top. Now here, my base is a 3 on the top and the bottom, so I just apply my subtraction rule to the exponents. 15 minus 4, so I keep the 3, and I just subtract, so that would be 3 to the 11th power. That's going to be a big number, so you're not going to multiply it out, you're just going to leave it like that in your answers on your homework. Now, here's the difference. Notice I have more y's on the bottom than I do on the top. If I say 4 minus 11, I'm going to end up with a negative number. So I would have y to the 4 minus 11, which is going to give me y to the negative 7, but I can't leave a negative on my answer, so it means that that answer with the negative on it is going to have to flip down and go below a fraction bar. So I need to rewrite this one as 1 over y to the 7th. Now, here's a thing to remember. If you think of this problem in this terms, I have more y's on the bottom than I do on the top. That means I'm going to be left with a bunch of factors here. In this case, 11 minus 4 would be 7, but because I have more of them on the bottom, it makes more sense. Just subtract the numbers and put your answer in the location where the more of the factors are. So notice that's what happened. If I subtract the numbers and I get a negative one, it's going to end up on the bottom anyway. So when I do this problem, the base numbers are the same. They both have 2's. And I have 5 on the top, but I have 13 of them on the bottom. So I'm going to take 13 and subtract the 5 from it, but that means the leftovers would end up down here. So I would simply have 2 to the 8th, and this would, I would put a 1 to hold that place, because this would have 13 2's written out, and this would have 3. So everything on the top would cancel off. It would be this problem flipped upside down. So nothing works on the top. Nothing's there on the top, but we put a 1 to be a placeholder, and we would leave 2 to the 8th on the bottom. So this would be your final answer. Now, if you subtract it, 2 to the 3 minus 13, is it 5? 2 to the 5, sorry, minus 13 is going to be 2 to the negative 8, but I can't leave it that way, so the negative 8 ends up coming to the bottom anyway. Now, there is one power number, and there is not a whole lot of rule to it. Any non-zero real number that's raised to a power, to the 0 power, if our power says 0, it's equal to 1. Okay? Regardless of what you think it should be, any number raised to the 0 power is going to be a 1 for the answer. So in this expression, everything inside this parentheses is being raised to the 0 power. So my answer is 1. Now, this one's a little different. The x is being raised to the 0 power, not the 3, just the x. So that would be 3 times 1, because x to the 0 would be 1. So 3 times 1 would equal 3. Now, on this problem, this y to the 3rd is being raised to the 0 power. So this expression is going to become a 1. And then I have 5 to the negative 3, so I just have 1 times 5 to the negative 3. So I just can ignore anything that has a 0 power in it. I can just ignore it. So here I would ignore this expression, and I'd only work with the 5 to the negative 3. But I can't have a negative, so I need to put it in the bottom, so I need it to go down. So my answer would be left with 1 over 5 to the 3rd. Okay? So here inside the parentheses, I have a whole bunch of stuff, but it's all raised to the 0 power. So my answer is 1. Okay, it's not rocket science. It's not a big deal. Okay, but that's just a 0 power rule that you have to do. Anything to the 0 power, it's a 1. It's just a 1. Now, the fifth kind of thing is a power of a power. So if we have a power inside and we're raising it to a power outside, these would be multiplied. Okay? If there's 2 numbers inside raised to a power, that means because they're inside the parentheses, that means both of these numbers are going to get that power, and you just stick it on there. Now, if these are understood powers, so if this is x to the first and this is y to the first, you basically are multiplying the power numbers, which are just like this. So whatever the power is inside is going to multiply times the power outside. Now, if you have a fraction raised to a power, that means the numerator and the denominator get that power. So here I have w to the third raised to the 5th power. So that means I would have to write w to the third 5 times. That's what exponents mean. But I don't want to have to write all that out. So if I think about it, that's w to the third, w to the third, w to the third, w to the third, w to the third. Now, if you count up all those w's, that's 3, 6, 9, 12, 15. See, I can get the answer by just simply multiplying these 2 power numbers together. So my answer is w to the 15th. Here, my base is a 2. The 2 doesn't get raised to the power. The 3, its exponent, gets raised to the power. So 3 times 3, I'm just going to multiply these 2 powers together. So that would be 2 to the 9th. Now, this one's a little bit different. Okay? The 2 has a power number that we just can't see it. It's an understood 1 right there. So if we multiply every exponent times the power outside, the 2 will become 2 to the 5th, because 1 times 5 is 5. The x's will become x to the 3 times 5 would be 15. The y would become 4 times 5, y to the 20th. Now, you might, in some cases, have to go back and then evaluate what this number would be, because you can actually get a number by saying 2 times 2 times 2 times 2 times 2. So 2 to the 5th can be simplified. If that's the case, we would end up with 32 x 15 y 20. And this would be the correct answer you'd be looking for. Now, here's a fraction. So everything in the fraction has to be raised to the power. So 2 is to the first power. 3 is to the first power. So I'm still going to use my powers here. Basically, if you have a number out in front, you're just going to stick that power on it, because it would be 1 times 3. So I'm going to have 2 to the third. Then a squared, so 2 times 3 would be a to the 6th. 3 times 3 would be b to the 9th. Now on the bottom, 1 times 3, so that would be 3 to the third. This a is to the first power, so 1 times 3 would be a to the third. B is to the 4th power. 4 times 3 would be b to the 12th. Now we have to go back and apply our division rule, because we have a's on the top and the bottom, and we have b's on the top and the bottom. We can't really do anything to simplify the 2's or the 3's, but we can make those be numbers. So 2 to the third power would be 2 times 2 times 2, which would be 8. 3 to the third power would be 3 times 3 times 3, 3 times 3 times 3, so that would be 27. Now, look at your variables that are alike. I have a's on top and a's on bottom. Do I have more a's on top or bottom? Well, this one has 6, and this one has 3. So subtract 6 minus 3 would be 3, but since the bigger number's on top, leave your answer there. So it would be just a to the third. When you get to the b's, the bigger number's on bottom. So your answer is going to end up on bottom, but just subtract 12 minus 9 would be 3, so I get b to the third. Then I don't end up with any negative exponents when I do that. That's a lot easier than worrying about subtracting the power and getting a negative number and then having to move it. So if we just look and see, I have more on top than I do on bottom, so my answer when I subtract will be up here. Here I have more on the bottom. When I subtract 12 minus 9, I'm going to have my leftovers be down on the bottom. So this would be your final answer. Now, here's a challenge problem. There can be a lot of combinations of powers and how you have to use all these rules above. So here's one of those situations. Everything inside the parentheses on the top and on the bottom have to be raised to this power. So 3 has to be squared. So that would be 3 to the first. So 1 times 2. Just stick the 2 on it. If it's got an exponent and it's got a number, just stick that exponent on it. Okay, then I'm going to go through the top. So multiply the powers. Negative 2 times 2 is going to be x negative 4. 3 times 2 will be y to the 6th. Negative 1 times 2 will be z negative 2. Then on the bottom, I'm going to be 6 to the second power. I'll just put it on there because this would be 1, and 1 times 2 would be 6 squared. Okay, 3 times 2 will be x to the 6th. Negative 5 times 2 would be y negative 10. Negative 2 times 2 would be z negative 4. Okay, now everything that has a negative exponent is going to have to switch places and move. Okay, so I'm going to circle anything that's got a negative exponent. Circle it so you can see it. Alright, so I got 3 squared. Well, that's 3 times 3. Okay, so that's 9. On the bottom, I have 6 squared. So that's 36. So I got that. Now, anything that has negative exponent has to switch. So this x to the 4th is going to come down, and I already have 6 x's down there. So when this one, change my pen, when this comes down, it's going to join with the 6 that are already there, and I'll get x to the 10th. Now this 10 is going to go up to join the 6 that are positive. Because it's negative in the bottom, it has to flip up. So 10 joins the 6, then I'll get y to the 16th. Now the z's are both going to switch places. So now I have z to the 4th and z to the 2nd because they just have to switch places. One goes up and one goes down. Now I look back and I simplify where I can. First of all, these two numbers, 9 over 36, they can both divide by 9. So I'm going to simplify that. 9 goes into 9 once, so that'd be a 1. 9 goes into 36 4 times, so 1/4. Now, all my y's are on top and they're positive, so they're fine where they are. All my x's are on bottom and they're positive, so they're fine where they are. Now my z's are in 2 places. I got more z's on top than I do on the bottom. So I'm going to use my subtract rule. 4 minus 2 would be 2, and since the bigger number's on top, my z squares will be left on top, and this would be your final answer. These are not really hard, but you do have to pay attention and you do have to follow the rules because those are rules that are going to be used a lot in this process as we move forward. Good luck.